Hi everyone, in today's lesson we'll be talking about a specific moment in my favorite anime, Katanagatari. To summarize what this anime is about, it's about a duo, Shichika and Togame. They travel together all across Japan to collect 12 specific swords, created by a legendary swordsmith. At this moment, Shichika is optimizing his ultimate technique to prepare for his strongest opponent yet. This technique consists of 7 of his strongest moves, and he's trying to figure out the best and most efficient order.
7つの奥義の順列組み合わせは5040通りだが
Togame stated that there are 5,040 possibilities. Not only is that a ton of possibilities, but how did Togame get that precise of an answer? Well, she used factorials. And what are factorials? Well, first let's talk about combinatorics. It is a branch of mathematics that revolves around counting. But it's not just like counting fingers. We're talking about counting the number of total possibilities, especially in finite space, which can result in ridiculously big numbers. So big that if you tried counting with your fingers, you'd probably cry when you mess up. When counting the number of total possibilities, you want to consider the number of options or events. The multiplication principle of counting is simply, if there's an A number of ways of doing something, and B number of ways of doing another thing, then just simply multiply it together for the total number of possibilities for doing both actions. The factorial function is a great way of counting outcomes, especially when your options gradually decrease with each choice that is made. A very popular example of people using factorials is considering the possibilities when drawing from a deck of cards. Every time you draw a card from a deck, 2 things happen. 1. The deck gets smaller by 1 card. 2. Also, since the card is no longer in the deck, you can't draw it again. So how do we use factorials? It's pretty simple to illustrate. Factorials are denoted as a number, or more specifically, an integer, which we will call n, with an exclamation point. What this means is that the number gets multiplied by every number before it until it reaches 1. Here's an example. Let's say we want to find out 4 factorial. Then it's 4 times 3, the number before it, then again times 2, then times 1. This means 4 factorial is equal to 24. So if we wanted to know the number of possibilities of 4 options that come one after another and don't repeat, then we would know that there are a total of 24 possibilities. Using the example in Katanagatari, we're using factorials because it's a sequence of 7 different moves, right after another, and they don't repeat. It fulfills the conditions that make it great to use factorials. With 7 moves, we will use 7 factorial. Doing the math out, 7 factorial is equal to 5,040, same answer Togame got. So for 7 consecutive and non-repeating moves, there are 5,040 possible outcomes. Great, we figured out how she did it. And this is just one of many applications of factorials. Because of its prominent use in finding outcomes, this means that it has a vital role in probability and statistics. There are also many ways to manipulate factorials. As also shown by Togame, a little later she found out that the number of outcomes can be reduced, since the first move should be the slowest move. Per her calculations, it heavily reduced the number of outcomes from 5,040 to 720, with the first move only having 1 outcome. Finding the combo looks like this. 1 times 6 times 5 times 4, down to 1 again. Or 1 times 6 factorial, which ends up at 720. Shichika had to perform 5,040 combos to see what had the best feel, but by understanding that the first move had only 1 possible best option, the number of combos were reduced to 720, saving a lot of time for Shichika. While on this topic, there are some other tricks we can use with factorials. When I mentioned how factorials were used with cards, one of its most popular usage is by applying winning percentages to poker hands. How about another scenario? Let's say Shichika wanted to use a shorter sequence of moves, let's say best 4 out of 7 moves. How do we calculate that? If I were to picture what would happen, it'd be 7 moves, then 6, then 5, then 4. From what we know in the multiplication principle of counting, it's easier to just say 7 times 6 times 5 times 4. However, we can also say 7 factorial divided by 7 minus 4 factorial, or 7 factorial divided by 3 factorial. This is an example of permutation. This is where you want to find the number of outcomes when the order matters, but the repetition doesn't. It is described as n factorial over n minus r factorial. This is the general formula, used for much bigger numbers. How does this work? First, let's use our example and write it out. Recall that when the numerator and the denominator are the same, it is equal to 1. And we know that when you multiply by 1, it stays the same. 1 over 1 equals 1, and 2 divided by 2 is equal to 1. And they keep canceling out. Notice how after we cancel up to 3 factorial, we have 4 numbers left. It is because of the n minus r factorial equation. We have n amount of choices, and we only want r of them. which we cancel out in this formula. So once we cancel everything out, what do we have left? 840. Why not just do this instead? Well, it's simpler to input it in a calculator, not to mention that with bigger numbers, it'll be a pain to write out. Endnotes. You may be wondering why I use Katanagatari. It's because this series is amazing. It's my favorite anime for a reason. 12 episodes of amazing characters, dialogue, and the most memorable ending I have ever seen. I do recommend people watch this series as it's heavily underwatched. I mean, sure, I could use something like Kagegurui to use any probability related video, and you're right, but who cares about being right in a math video? Speaking of probability in card games, the reason why this video is so short is because it's essential in covering the next video. There was a word I really wanted to avoid in this video, and it was combinations. In the next video, I will be talking about what it means in terms of probability. We're going to be using what we learned today and apply it to yet another popular anime that uses cards, Yu-Gi-Oh! If you like this content and want to see more of it, please like and subscribe, and I'll see you next time.